Hi, and welcome to video 12 of the QuickStart series for the Analog Discovery 2. In this video, we'll go over the logic analyzer. Logic analyzers are used to record and analyze digital communication signals. They work in a similar way to an oscilloscope, except the data is processed and displayed with some additional data that's calculated by the software to help with analysis. With the Analog Discovery 2 and WaveForms 2015, you can record and analyze most types of digital communication signals. You can access the logic analyzer through the 16 digital input and output channels. Click the Logic button in the WaveForms navigation bar to open the logic analyzer. Once in the logic analyzer, you'll see 4 familiar menus: File, Control, View, and Window. The File menu allows you to open a new logic analyzer instance, open an existing logic analyzer configuration, save the current logic analyzer instance, export the data as a text, CSV, TDMS, or image file, or close the logic analyzer. The Control menu gives access to the single run and stop acquisition buttons. The View menu opens different windows to help you view and analyze the captured data. Data displays all of the captured window data in a table, with time and channels in the columns. Events allows you to traverse through the data via captured events. Logging allows you to log and save data. Cursors allows you to add cursors to take normal and delta measurements to further analyze your data. Window lets you switch between any of the open WaveForms 2015 windows and tabs. Below that, you'll see the logic analyzer controls. The single button allows you to capture one window worth of data. You can adjust how much data this captures by adjusting the time scale. You'll need to make sure you have enough samples in order to get a good enough resolution. Run will start a continuous acquisition. Once you hit Run, this button will turn into the Stop button. Mode allows you to change how the data is displayed in the plot window, either one full plot at a time, real-time that wraps around once the end is reached, real-time side-scrolling, or you can record the data. The logic analyzer uses computer memory to store past data acquisitions in a buffer. Buffer keeps a running tally of which buffer you're currently using. If you click the green plus, you can save the currently shown acquisition data into a new tab. There are several ways to trigger the logic analyzer. The Trigger dropdown allows you to select a trigger mode. If Auto is selected, the tool will wait about 2 seconds once started. If no trigger is detected, the acquisition will start automatically. Normal will place the tool in an ARM mode once started, until the determined trigger condition is met. None will ignore all trigger settings and immediately start acquiring data once the tool is started. Source allows you to select the source of the trigger. You can use the static I/O, oscilloscope, waveform generator, pattern generator, external trigger channels, or a manual trigger. If you click on Pulse, it will open the Pulse configuration window where you can set a pulse trigger. The Glitch tab triggers the acquisition when a single pulse shorter than the specified time is registered. The Timeout trigger triggers the acquisition when a signal pulse longer than the specified time is registered. Length triggers the acquisition when a signal pulse of exact length with the given hysteresis is registered. Counter looks for a set number of specified edges before starting an acquisition. The last trigger option is Protocol. Since we have to add channels before we can use those trigger settings, we'll wait to go over those options until we've talked about the protocols. Below that is Inputs. For the Analog Discovery 2, the maximum sample rate and number of inputs is fixed at 100 megasamples per second and 16 channels, so you don't need to worry about this. For other devices that connect to WaveForms 2015, such as the Digital Discovery, the maximum sample rate depends on the number of channels. To the right of that are Base and Position. Position allows you to set the position of the middle of the logic analyzer window, and you can select anything from -500 hours to 500 hours. Base allows you to change how much data is displayed in the window. This will be important when trying to view the decoded values or using data in further analysis in the script editor. You can select any value between 10 nanoseconds per division and 2.4 kilohours per division. Clicking the green arrow will open 2 additional settings, Samples and Rate. Here you can set the number of samples and rate of sampling. You can select Default, or anywhere from 32 to just over 33 million samples, and 10 millihertz to 100 megahertz for rate of sampling. Clicking on the gear will open additional options. You can change the position to be displayed as divisions instead of seconds, change the time base to full in seconds, division in seconds per division, or plus minus in seconds. You can change the clock source, remove or add noise, select between 1 and 1000 buffers, clear the buffers, select to draw while recording, and change the update time. Below the trigger settings, you'll see the grid where you can add and view digital channels. Clicking on the green plus sign will open a menu to add a single or bus channel. The red minus sign will allow you to remove a specific channel or clear all channels. With a channel selected, clicking the symbol with a piece of paper will open the Properties window for that channel or bus. This is the same Properties tab that we'll talk about when we add each type of signal. With the channel selected, clicking the T will open the menu to specify how that specific channel is triggered. You can select Ignore, Low, High, Rising Edge, Falling Edge, or Edge. Below that is the grid where you can see the single or bus signals that have been added. You can view their name, properties, pin numbers, trigger setting, and the signal itself. As mentioned before, clicking on the plus sign will allow you to add a single or bus channel. To add a single signal, click the plus and click on the signal. This will open the Add Signal menu that will show the available digital I/O channels that can be used. The name defaults to the pin name but can be changed in the properties. You can access the properties by clicking on the symbol with a piece of paper. For a single channel, you can change the channel that's being used. Next to that is the pin name and the trigger option that we discussed earlier. Next, let's add a generic bus. Click on the plus again and click on Bus. This will open the Add Bus menu. Here you can add available channels, select an enable or clock signal if there is one, select the format that the data will be displayed, select the endianness, and select the most significant and least significant bit. For format, you can change between binary, decimal, hexadecimal, vector, signed, ones complement, twos complement, and binary coded decimal. Clicking on the Properties icon will allow you to edit all the settings we've just gone through. Next is a SPI bus. Click on the green plus and click SPI. This will open the Add SPI window that allows specification of the SPI bus you intend to decode. At the top, you can change the name. Below that, you can change the chip select, clock, and data lines. You can choose any of the 16 digital I/O pins. To the right of that, you can specify if it is active low or high, whether it is sampling on the rising or falling edge, and whether the most significant bit or least significant bit is first. Below the channel selection is the options for the data. You can specify the number of bits in your SPI bus, how many leading and ending bits there are, when you want it to start, and how to display the data. The data can be displayed as binary, decimal, hexadecimal, vector, signed, ones complement, twos complement, and binary coded decimal. You can choose to start the bus between 0 and 10 seconds. The next type of bus that can be decoded is I2C. Click on the green plus and select I2C. This will open the Add I2C window where you can change the name of the bus and select the clock and data signals. Again, you can choose any of the 16 digital I/O. Another type of bus that can be decoded is UART. Click on the green plus and select UART. At the top of the Add UART menu, you can change the name of the bus. Below that, you can select the data line from any of the 16 digital I/O channels. Below that, you can choose between standard and inverted polarity. Next, you can select the number of bits, the parity, either even, odd, high, or low, the number of stop bits, and the baud selection. If you choose manual, you can select the baud rate in the drop-down below. You can choose between 110 and 921,600 in standard baud rate values. Lastly, you can choose between 0 and 10 seconds to delay before starting. The next type of bus that can be decoded is CAN. Click on the green plus and select CAN. At the top of the Add CAN window, you can change the name of the bus. Below that, you can change the data line, polarity between high and low, rate between 20 kHz and 1 MHz, and delay between 0 and 10 seconds. Another type of bus that can be decoded is I2S. Click the green plus and select I2S. At the top of the I2S window, you can change the name of the bus. Below that, you can select the select, clock, and data lines, and number of bits. You can select low as either left or right, sample as falling or rising, first bit as most significant bit or least significant bit, shift as one or none, align as left or right, and select the format the data will be displayed. Data can be displayed as binary, decimal, hexadecimal, vector, signed, ones complement, twos complement, and binary coded decimal. The final built-in signal that can be decoded is Onewire. Click the green plus sign and select Onewire. In the Onewire window, you can change the name of the signal, select the data line, and change the polarity of the signal between low and high. Lastly, if you don't see the communication protocol that you need, you can use the custom signal type. Click on the green plus sign and click on Custom. This will open the Add Custom window. Here you can use the script editor with some basic decoding functions to write a custom decoder. The Example tab has examples for bus, SPI, and UART. The Value to Text tab contains the value to text script and will be called when a value needs to be displayed. More information about the script interface can be found in the Help tab. Now that we've gone over each type of protocol, let's go back to the protocol trigger options. Click on Protocol and you'll see a menu with all the protocols that are in the plot window. Click on Bus and it will open the bus trigger window. Here you can set the trigger value. Click on SPI and it will open the SPI trigger options. Here you can set the trigger on start, stop, or a specific value. Click on I2C and it will open the I2C trigger options. You can set the trigger to start, stop, any acknowledge or not acknowledge, or address and data. Address or data allows you to specify the consecutive address and data values or ignore it. Read-write lets you select between read, write, or to ignore the operation type, and acknowledge lets you select between acknowledge, not acknowledge, or to ignore the acknowledgement. If you click on UART, it will open the UART trigger menu. Here you can set the trigger to break, idle, or a specific value. Value allows you to specify the value to trigger on. Clicking on CAN will open the CAN trigger menu. Here you can select to trigger on error, break, or a specific identifier. Extended lets you select between 11 and 29-bit identifiers. Identifier allows you to specify the specific identifier to trigger on. Request lets you select between data, remote, or ignore request types. Bytes allows you to specify the data selection byte length, or you can ignore this field. Clicking on I2S will open the I2S trigger wizard. Here you can select between the right and left channel trigger, specify the value to trigger on, and specify the number of clock cycles in a frame. Clicking on Onewire opens the Onewire trigger wizard. Here you can select between triggering on reset or a specific value. Speed allows selection of between standard and overdrive. Command specifies the command to trigger on, and family specifies the family field to be triggered on. Now you know some basic information about the logic analyzer. In the next video, we'll go over the pattern generator. Subscribe to stay up to date to Digilent's products and services. Thanks for watching!